Let's look at the second objective. I can simplify complex fractions by multiplying by a common denominator. Notice that we have two steps. So it seems a little more straightforward compared to the previous method we looked at just recently. We are going to multiply the numerator and the denominator of our complex fraction by the least common denominator. And then we're going to simplify. This method looks really intimidating at first, but as I started to do the work, I think it actually might be a little faster. You can use either method when it comes to doing your homework. I'm not going to ask you specifically to use method 1 over method 2. It's whichever method you feel most comfortable using. Both are valid methods. So our first example is a problem we have already done, but I'm going to show you how to solve this using the new method in this objective, which is identifying first the least common denominator. Remember, it helps if you know what your first main fraction bar is, and then identifying what your denominator is in your numerator, which is x plus 2, and your denominator in the denominator is x minus 2. And if you're trying to establish what the least common denominator is, your denominators must be factored, which they are, and every factor is invited to this party unless they are already present at the party. X plus 2 going to the party. X minus 2 also going to the party. Once you have established what your least common denominator is, you multiply everything by your least common denominator in your numerator and in your denominator. So this is, like I said, going to look pretty intimidating. You're going to multiply x plus 2, x minus 2 to 5x over x plus 2. That's your numerator of the complex fraction. In the denominator of the complex fraction, you're multiplying by that least common denominator to 10 over x minus 2. By now, you probably have recognized when you multiply by least common denominators, common factors divide and cancel out. That's supposed to be a plus. That way it doesn't look like a 12. All right. Common factors cancel, they divide. So here we go. The x plus 2's cancel in the numerator. And in the denominator here, the factors of x minus 2 divide. They cancel. In my numerator, I now have an x minus 2 times 5x. And in my denominator, I now have x plus 2 times 10. So now I just have one simple fraction as opposed to a complex one. That, if you noticed, kind of just cleaned itself up very nicely. And I can continue now by simplifying further. 5 and 10 is equivalent to 1/2. And it looks like that's all I can simplify, which is good because my final answer, if you recall, I wonder if I can, oh my gosh, I've still got it. Okay. I can simplify this. Okay, I don't still got it. Switching between colors is a chore, let me tell you. There we go. 1 times x, which is x, and x times x minus 2. In the denominator, 2 times x plus 2. And if you check your notes in the previous example, that is exactly what we got. Okay, notice how it seems really, really horrible at first, but it cleans itself up very nicely. We're going to repeat that process with this example, which looked really, really bad in the first round in the first objective when we simplified this. Identify your main fraction bar and focus on identifying the least common denominator of your numerator. In your numerator, your denominators are y squared and y. The least common denominator would be y squared. In the denominator, your least common denominator would be x squared. So your least common denominator of the whole fraction, the whole complex fraction. I'm gonna erase that. Go ahead and erase that, strike it out. Or you can just say least common denominator of the numerator and the least common denominator of the denominator. Oh, I almost wrote demon, denom. Okay, the least common denominator of the whole complex fraction is both of these denominators multiplied together if they're not already at the party. That's y squared and x squared. This means I am multiplying y squared and x squared to x over y squared. I'm multiplying y squared and x squared to 1 over y, all over y squared and x squared being multiplied to y over x squared, plus y squared, x squared multiplied to 1 over x. Looks pretty bad. It looks terrifying. It's giving nightmare. So let's clean it up and let's cancel out common factors. These y squareds, y to the second or y squared is going to simplify, cancel out and divide. This y is going to cancel or divide one of the y's in that factor there. Looking at my denominator now, these x squareds divide and become 1. This x simplifies one of the x's that I have. So in my numerator of my complex fraction, I now have x squared times x, which is x to the third, and x squared times 1 times another y right here. That y hasn't gone away. So I have y and x squared. In the denominator, I have y squared times y, which is y to the third, plus a y squared times an x to the first. And I'm going to simplify. In my numerator, I have a common factor of x squared. That leaves me with x plus y. In the denominator, I have a common factor of y squared. That leaves me with y plus x. And I can simplify y plus x and x plus y because addition is commutative. Order doesn't matter, meaning I can simplify this to be, let's see if I can move. Oh, I don't still got it. Let's try that again. There we go. My final answer is going to be x squared over y squared. Okay. Is there one more example? Give me a moment. No, that's the end of this video. All right. I'll see you in the next one. Thank you for watching.